So my main concern is software development, and security is just one of the aspects that I deal with. Now, in the development community, security tends to come as an afterthought, and I try not to do that in my professional practice. And in order to help change that mindset, yes, can you hear me now? I was saying that in order to change the mindset which considers security as an afterthought, thank you. I've set up a non-profit organization which runs courses for developers where we try to raise awareness on security and where we try to improve developers' skills on the security front. Now, thank you very much for coming so numerously. I'm in awe. Now, I'm not sure what you're expecting from this presentation because it was actually announced as Code Secrets, and I don't know where that title came from. It didn't come from me. I'm actually going to talk about security architecture, and so if that is a disappointment for you, then I completely understand if you wish to leave, because in fact there is very little. No, I shouldn't say very little. There is no code in my presentation. Well, my line of attack in talking about security architecture is the following, really. I plan to present you with a series of platforms, and that should all lull you to sleep. And then I'll catch you unawares, and I'll present you with some very surprising guidelines of where to place code and how to do it. But then, by then it will be too late, because it will be irrefutable. But having said that, if you are awake, please give me some feedback. Talk back to me. The room isn't very conducive for a discussion because there is this light beaming at me, so I can't see. I can't see you terribly well. Sorry?
There is no one in the room.
There's no one in the room. It's not just there is not just a projection here. There is also a projection there. But yeah, I'm very aware that in this room there is some of the world's best expertise on this matter, and I'm very keen to get some feedback on and to increase my own understanding as well. So if you have questions or comments during the presentation, please interrupt, and afterwards I'd love to have more feedback too. So what I want to do is to demonstrate some of the thinking when building a system, how you balance security against some of the other concerns of the stakeholders, and how you deal with imperfect platforms. So I want to illustrate this thinking with an example. It's a project that I worked on in the last couple of years, and the topic is quite topical. The case study is quite topical. It's a system that tracks securities as debt collateral. Now, my apologies for the fact that the word security will be overloaded as a consequence in the talk, but I think it should be clear from the context which kind of security is meant. And if it isn't, please speak up and ask for clarifications. The recent events in Wall Street, I think, have helped to put into sharp focus what the implications, what the potential security implications are of a breach of such a system. Now, it's obvious that the current crisis wasn't wasn't caused by a software failure, but still the impact should have become. Now, I'm going to limit myself in the discussion to what I'd like to call the data integrity. And by data integrity, I mean the integrity according to the business rules. So I'm not going to talk about all the kind of fancy stuff that usually gets discussed in Owasp meetings, like cross-site scripting or surf, etc. I'm just looking at the problem of making sure that the data in your database is actually consistent with the business rules. So one thing that springs to mind, and it's an example that I'll bring up several times in my talk, is a security that acts as a collateral for a debt, for a loan, needs to be rated. It needs to have a valid. Yeah, and so whenever you have the flag in your database ticked saying, yes, this is a collateral, then this valid rating needs to be there. So that's the kind of thing that I want to talk about. Everything else is out of scope, by the way. This is not untypical. I find at clients that this data integrity concern is often that is foremost in their mind. Things like confidentiality and even availability tend to come lower down the list of priority. Not in all systems, but often that's the case. The set of measures that we are going to apply in order to ensure this data integrity, I'll refer to as the validation architecture. So it's fairly rare these days that you get to build a greenfield system, and this system is no different. It's a brownfield. It's an existing system, and the assignment was to do some maintenance on it. So what I'm going to do with you is to look at the system and identify flaws and think about how we can fix them. So it's a very, very simple system, actually. Conceptually, it's a very simple system. It just does the usual create, read, update, and delete on securities. It presents the user with forms that allow him or her to create a security. There is another form that allows the user to update the security. There is a form to specify search criteria. And then there is a page with search results, and that page then contains a link that allows you to view details of a security, to open the modification form, and also there is a button for delete. That's all there is to it. The architecture is a very classic one, and I hope that it will be, some of the thinking here will be useful for you in the sense that it is such a classic architecture, and you're likely to encounter it as well. So it's a classic Java EE three-tier architecture with a browser connecting to a web server, which runs a struts MVC, model view controller, application, and the model hands off to the business logic on the application server, which in turn connects to a relational database management system. So when I looked at the application, what I noticed was that there was an awful lot of validation. In fact, it looked as though the developers had put all the validation that they knew how to on every tier. So at first sight, this might look like defense in depth, but I'm not so sure whether it is, and I'll be going into, I'll be examining that question. So let's take it one step at a time, and I'd like to start from the back. I'd like to start at the side. And so what we have is a data tier which receives a prepared statement and interacts with the application server that way. And in the data tier, we have a number of constraints formulated in the database as some fields that are null. We have referential integrity constraints. There are some constraints imposed through the data types in specific columns, which might specify the precision of a number, the length of a text, that sort of thing. And you have unicity constraints. Now on the application server, you have an enterprise Java bean, and that exposes two methods, validate and store. And as a parameter, these two methods take a data transfer object, or DTO, and the DTO really makes the link between the form and the database, in the sense that for each field in the form on the web front end, there is a property in the DTO, and for each field in the database table, there is also a field in the DTO. There is a property in the DTO. And so that DTO gets fed to the EJB. So the interaction between the web tier and the business tier is a two-step one. So in the first step, you validate data that you want to write to the database, and in the second step, you actually perform the update. So which incidentally I've shortened here as store. In fact, there are three methods: create, update, and delete. So why would you organize that way? Well, the reason is that it's a very convenient way of well, basically the user interaction is organized that way, and so that reflects on the architecture of the application. So the user basically has to do this validation step first. Well, the user first fills in all the fields, does this validation step, and then he gets the data back, but all the fields are blanked out, and so the only thing that he can do that at that point is to do cancel or submit. Yeah? A naive user, in any case, can only do cancel or submit. An attacker, of course, could then go and use another tool to submit the data anyway. So the question is this foolproof? And most of you will have doubts about that, I think. But I'll come back to that point later. Let's first look at the web server. So that's the struts model, and I really don't want to go into that very deeply. I tend to find the struts data flow often quite difficult to understand. It seems to be somehow counterintuitive, and also what I also dislike about struts is that you have an awful lot of configuration to do in XML files, and I find the distinction between what you do in Java code, the so-called coding, and the configuration job, I find that distinction often rather arbitrary, which tends to mean that the whole thing is more difficult to understand than it needs to be. Yeah, the trouble with the data tier is first of all that it's in struts, but maybe it's my prejudice. But more importantly, the validation code that's in that tier is in fact cut and pasted from the business tier, or vice versa. Okay, so we have code duplication here. So let's look at the browser. Now the browser is the data entry point, and as such, it's validating the fields on entry. It does so in JavaScript, and some of these validation routines are hard-coded in the JSP, and some of them are assembled dynamically. So, for example, if you what's a good example now? So there are some regulations that need to be filled in, that securities have to comply to, and the date of the regulation indicates the version, and these dates can only be a number of options, so that is pulled from these options are pulled from the database and used in the check. So let's have a look. Let's critically look at the validation that's happening in the browser. I think that what's good about it is that it enhances the user experience. The validation done in the browser is fast. There is not the round trip from the browser to the web tier, possibly even further. You have immediate return, and also the granularity of the validation is very fine. So for each field, you get an immediate error message when you fill in the wrong, an implausible value. And so in order to work, well, that improves the user experience, and through improving the user experience, the user is able to work more effectively or more efficiently. Now, what's not so good? Well, these checks are only on a field-by-field basis. Now, in fact, some of the constraints that need to be imposed, that need to be enforced, are across fields. So I gave you an example. What was the example again? Yeah, the collateral. Sorry, if a security is to be used as collateral, then it has to have a valid rating. Okay, so since the fact that it's used as a collateral is a Boolean flag, and that's one field, and then the rating is another field, and then the validity of the rating is another two fields, one being the start date of the validity of the rating, and the second being the end date. You need to tie all these fields together in order to do your validity check. Now that's not being done, or that was not being done in the application. For that kind of thing, yeah, sorry? Why would you not say, sorry?
I don't trust anything coming from the user. So any kind of validation, any kind of check run in the browser,
I wouldn't rely on that anyways.
Okay, that's a good point, and I will be addressing the measures that should be taken. Now, at the moment, I'm describing the system as is, and the system as is or as was would indeed not trust user input, because the validation would happen in the later tiers as well. So you would check in the browser, you would check in the web tier, you would check in the middleware container, in the EJB container. So user input would be checked in all those phases, and it wouldn't get to the database. Is that an answer to your question? Sorry?
I don't mean to harangue you.
I still didn't get it. Okay. So and something else that I didn't like is that the validation code wasn't exactly a copy and paste from the code in the web in the middle tier, because you have different formalisms in these different tiers. You have JavaScript on the browser, and you have Java on the web and in the EJB. So you can't just copy and paste it, but in essence, the logic is a duplicate. So let's go back to the question whether this is defense in depth. Well, I don't know what you think, but I don't think it is, because defense in depth is not just repeatedly doing the same thing over and over again, and the more often you do it, the deeper the defense is. Defense in depth is about making sure that if one component fails, then there is another one that will resist attack. And that's not the case in this here. So one attack path would be an insider who would have access to the RDBMS. That's a kind of obvious one. And then another one would be on the interface between the web server and the server. How would you do that? Well, I don't really want to go into too much depth here, but some suggestions for an attack path. You could impersonate the web server. You could interpose a man in the middle between the web and the EJB container, or you could compromise the web server. So what are the problems with the architecture as is? I think problem number one is that the trusted computing base is too large. In fact, what we have is just about everything being in the trusted computing base. If you, for example, want to rely on the validation in the web server, then you need to trust, first of all, the validation, which is not too bad, but you also need to trust that all the subsequent handovers of the data flowing through the system also preserve integrity. So basically you end up with just about everything being in the trusted computing base. And the problem with that is that the larger your trusted computing base is, the harder it is to convince yourself that you got it right. Even if you are able to convince yourself once that this is the case, each time that you make a change to the system, you have to go through the whole exercise again. Okay, so that's why you want a small TCB. Second problem is code duplication. The problem with code duplication is that it breaks the focus, the focus of concern of the code. And again, it means that you have a maintenance nightmare on your hands, because invariably your business logic change, the rules of the business change due to different regulations, due to different financial instruments coming onto the market. That means that all that duplicated code has to be changed. In the end, that is a security issue as well, because developers are invariably under stress. They are invariably under stress and have to work to tight deadlines, so corners get cut, hence the system will not be maintained in the integral state, will not guarantee the integrity that it should. So how do we go about solving this problem? Well, you could massively reduce the size of the TCB by enforcing the data integrity in the database. It's like, you know, the data are your crown jewels, and what you want is to protect, to put your protection as close to those crown jewels as possible. Now, how can you do this? Well, we had some validation in the database, remember. We had we had specified the data types of the columns. Some columns were not nullable, unicity, constraints, referential integrity. Now we can supplement those constraints. Those are not enough to express all the kinds of constraints that we want to express. But we can supplement those with, for example, check constraints. Constraints can do a check across different columns in a row. So, for example, the example that I gave previously, where I said a security that acts as collateral needs to have a valid current rating. Those are all fields in the same row. Okay, so you can express that with a check constraint. Now, databases also allow you to specify triggers, and they come in different varieties. You have per statement triggers, and these triggers can be executed before the statement, or they can be executed after the statement. You also have triggers that can be executed, that are executed each a row is updated, and it can be executed before the update, or it can be executed after the update. Now, the before one is an interesting one, because in most RDBMS systems, it's possible to get the transaction to abort if the trigger returns a certain value. Null, for example. So what you can do is you can write a SQL statement that will return nothing if a constraint is not satisfied. And so this SQL statement can access basically the whole database. Okay, so this is pretty powerful. Yeah.
I have a question about this. I really don't agree with this setup, because you're talking about code duplication, and now you're duplicating your business rules from your which should be in your business layer to your database layer.
Okay, this is the classic comment that I would expect. No, I don't think so. I'm going to remove the code from the business layer.
You're removing it. Okay.
So my assertion is that you can capture just about all the constraints that you're going to need in this fashion. I'd say about 99% of the business rules enforcements you can capture in this way. Now, for the more exotic ones, there are procedures. Okay. So now I want to come to the question of what should be done with the other validation rules. The other validation code that is still sitting in the business tier and in the web tier and in the browser. Should we just leave it there? Well, you pointed out that if we do, then we would create even more duplication. So that's not an option. We shouldn't just leave it there. You don't want to leave it there because you don't fulfill the dry criteria. Do you know the acronym DRY? Don't repeat yourself. Okay, so we want to be dry. To be dry because that will drive our maintenance costs down. And as I said, a high maintenance cost will reflect on security. So should we just eliminate, as I glibly stated earlier? Well, not quite. There are some other concerns that may be addressed in the other tiers, and I'll go into detail about some of the concerns later on. But I immediately want to say, probably there are things here that are out of scope of this talk, namely things like cross-site scripting and CSRF that you really do want to do in the business layer and in the web tier. But for now, I would say get rid of the code. If I'm just talking about data integrity, get rid of the code dealing with the protection against data corruption in the business tier and in the web tier. But the browser, that's another matter. What I've shown you so far gives you, I think, very good protection against a malicious user. What it doesn't give you is protection against the incompetent. Well, I call it rather glibly incompetent user. But the fact is that the rationale for the web application is to make data entry more effective, more efficient. And so usability is a prime concern in the web application. So you should read the incompetent, well, I use the word incompetence as a shorthand for saying all those things that have to do with making it easier for the user to enter the intended data. In fact, John Stephen had another pair of words for the same two concepts in the previous talk, and that was, he called what I call malice, he called evil, and what I call incompetence, he called dumb. It's the same thing. So my contention is that you should validate to protect against malicious users near the data, and I've shown you how I plan to do that, and to validate to enhance the user experience near the user. So basically we've sort of migrated the validation to the extremes. So there was complete validation here, and there was validation here and validation there too, but they were not complete. So I've shown you what I would do at the back end. What about the front end? What about the browser? The first mission of the browser is the first mission of the browser code is to provide a great user experience. And in order to do that, you need to embrace JavaScript. So we had some JavaScript in there, but we need to push that much further. We need to do what I said earlier. We have to tie those different fields together by adding JavaScript onto submit button, for example. We also need to do some dynamic checks. For example, a security can only have a value that is compatible with the issuance program that it belongs to. And so that's data that needs to be got from the back end. And so you need AJAX calls as well. Having said that, I'd like to talk about error messages, because that's something that I swept under the carpet up until now. The reason why, one of the reasons why people don't like putting validation code in the database and relying on that validation code is because it's so darn difficult to get good error messages to the user. What happens when those validations fail is that you get an exception is thrown in your Java code, and it will probably give you a SQL code, and it may give you some text, and you could actually go and parse that and look that up in tables, etc. But it's a nightmare to do that. So that's why people don't like doing that. Now, in fact, if you have this validation at a too extreme, the issue doesn't arise, because since you're doing validation, since you're doing exhaustive validation against stupidity of the user in your browser, you can do your error handling there. You can give excellent feedback on what the user is doing wrong there. And if it happens that something is rejected at the database level, then there are two possible reasons for this. One is that there is a bug and you should fix it because, well, basically you've missed a case, or an attack is going on. And if the latter is the case, the last thing you want to do is to give an error message back. You may want to do other things. You may want to raise an alarm or shut down the system even, but you don't want to give an error message back. So, yeah.
It seems like there's some, where would you do your authorization and validation? Would you do those at the database layer as well? Because it seems like those routines might have to act on the data. And if the data's not good, you could cause those things.
I would like to do authorization at the database level, yes, but in most shops that would have such a high impact to do that it would not be feasible.
It seems like that assumes, in many cases, good data, or you're the data in some way, and there's other intermediate processing other than authorization and validation that you might be doing in between the two extremes.
Sure.
That assume good data.
Yeah.
Yeah. So how would you handle that case in this? And if you want to wait on that, we can.
Yeah. I'd like to take that offline because
Okay.
that's actually a huge topic.
Okay.
Yeah.
I was at work for one firm where the architects declared access to the database or update of any kind of update needed to be done with stored procedures.
Right.
And that all view access, read access should be done through views.
Right.
So, I mean, I guess that seems consistent, although
I sympathize entirely with that view. Yeah. Okay. So let me examine the drive principle again. So we've got rid of an awful lot of duplication. We just got rid of all that code that was sitting in between that wasn't really serving us terribly well. But unfortunately, there is still an overlap between the validation on the browser and the validation on the database level. And to be honest, I can't quite see a good way of getting rid of it. So let's just reflect on that. First thing I would like to say, there is nothing wrong with checking something twice. That's not actually against the dry principle. The dry principle is about code duplication. It's not about runtime duplication. If the same code gets invoked multiple times, that's not going to cause you any maintenance upsets. Now, having said that, our code does express the same test, the same validation twice, once in JavaScript and once in SQL, and I can't quite see a way of getting rid of that. Now, as a consolation, I can say, well, if you express the same integrity constraint in several formalisms, and that's, after all, the reason why we still have that duplication, because we're forced to express it in two different formalisms. But an argument could be, you could make an argument for saying at development time, it helps you covering the range of validation that needs to be done by expressing it in different formalisms. So that can bring you some advantages. I'm not entirely convinced by that argument, and I would like to see a technology stack where a single source can be distributed over several tiers. I was going to look at some possible candidates that sort of think along those lines, but I'm running out of time. The essence of the thing is that Ruby on Rails basically relies on code generation in order to allow you to express everything in quotes in Ruby. At the end of the day, although it's true that you can express it all in Ruby, you can't do the validation actually in the database, and you can't do the validation actually in JavaScript in the browser as we would wish to. GWT goes a little bit further in the sense that it compiles Java to JavaScript if it's executed on the client side, and so the same code can be run on the server and on the client. So you have the same code running on different tiers. But you can't do your validation in the database there either. To conclude, I think it's important to make a clear distinction between two things. You want to protect against two different things. One is what I called malice, and the other is what I call incompetence. To mix them up is going to make you end up with less than ideal code. My advice would be to protect against malice at the very last possible moment, and to protect against incompetence at the very earliest possible moment. And of course, if you do take something away from this talk, remember that it's important to keep dry. So, are there any further questions or comments? Yes, please.
Have you considered the modular-driven approach to this problem? For example, imagine an annotated UML model of your data and let that drive your validation logic in several fields?
I'll be the second mouse on that one. You know, the first bird gets the worm, but the second mouse gets the cheese. So, you know, on model-driven architecture or model-driven development, I'll be the second mouse. I'll let someone else demonstrate that it works. Anyone else? Yes.
I think that you presented us a couple of architectural patterns in implementing security. And my question is, have you ever done a comprehensive set of security patterns that might be as influential as the design pattern being on to the object-oriented program?
There are certainly efforts along those lines. Are they as influential? I think it would be hard to be as influential as the Gang of Four patterns. But I do think that there is a lot to be said for that of thinking in architectural patterns. Yeah, I don't know. Does that answer your question?
Yeah. Can you give a couple of examples? Yeah.
You mean of patterns?
Yeah.
Well, I hesitate because I'm not sure that the correct definition or the useful definition of security pattern has emerged yet. I mean, I've heard things like authentication be referred to as a pattern. I'm not sure that's useful. I mean, a firewall, for example, that seems to me to be a useful pattern, or it seems to be useful to think about a firewall as or firewall as a pattern. So I'm not quite sure how we should approach patterns in security work. Okay.
Well, me personally, I don't agree with several things that you said, but my question will be related to just one of them. You said that maintenance costs will go down, so from my understanding, it will be much to maintain the business logic and all those checks on the
In database.
Yeah,
Okay.
especially if the business rules change very dynamic. So can you elaborate on that?
Okay, that's. I'm very grateful for that question, actually. I think that time and time again. Well, no. Let me start in another way. The classic argument for putting all the business logic for putting all the enforcement of the business rules outside the database is because one day you may want to change your database. Yeah, that's a classic argument. Do you agree?
Yeah.
Okay. I have never seen this happen. Okay. Databases always, in my experience, outlive the applications. Yeah. Applications are thrown away and rewritten. Data isn't. Really, that's where your crown jewels are. And so I think that what you just said gave me one more argument for doing it this way. Because you want these business rules to persist across these application instabilities and changes.
I've been involved in several projects when actually they realized that the database schema is not very good, so they basically restructured the whole database and they imported the data in the new schema, so using the new schema. So how that would work in this case?
Well, actually, that was the assignment. The assignment was the database. Now, it's a critical database, it's a mission-critical database, and the database has to continue to live throughout the restructuring. Does that answer your question? Okay.
I think one problem that I have with the philosophy is that I'm not sure that data languages are sophisticated enough in many cases to handle some of the business logic problems that one would face. And it depends on the database too. I mean, I guess, so I think of some of the more sophisticated, like object-oriented databases that people have come up with, where there was an ability to build a more complex architecture that could handle more complex business logic. But code stored procedures on a SQL server to encode my logic. I kind of agree with the notion that it's not that maintainable because they can be more confusing to read than Java.
Well, although in Java, at the end of the day, the operations on the data are going to be done in SQL. My view would be that, well, why not code those constraints in SQL? And SQL is actually a very expressive and maybe not quite ideal, but pretty good language and pretty legible language when you are doing data operations. My experience is that in the vast majority of cases, statements are quite sufficient to express the constraints. And if they're not, stored procedures are enormously expressive. You can write stored procedures in...
Is the lack of tools for developing stored procedures properly.
Well, I mean, you can write stored procedures in Java, in COBOL, in Ruby. You can just about use any formalism, depending, of course, on your specific database. But if you have a little bit of luck, then you should find a language to your liking there.
We do have one more session in this room
Okay.
today, so I think we're going to have to cut the questions short. We'll just thank Johan. Maybe you could grab him afterwards, ask him a question.